All right, let's talk Node.js. You've probably heard the big claim, right? That it powers these huge, massive applications with just a single thread. I mean, how is that even possible? It sounds like it should just grind to a halt. Well, it turns out it's not magic, it's just a few really clever ideas. And today, we're going to pull back the curtain and see exactly how it all works. So to wrap our heads around this, picture this. You've got a packed restaurant, tons of tables, everyone's hungry, but there's only one chef in the kitchen. Just one. Now, in any normal kitchen, that's a recipe for disaster, right? Total chaos. But what if this chef isn't normal? What if they have a secret weapon? That's kind of the whole puzzle of Node.js. And this chef, well, they're going to be our guide. So what is this big secret? It's a little something called the event loop. This is the absolute heart of Node.js. Think of it as the non-blocking engine that turns our one-person kitchen crew, our single thread, into the super efficient coordinator that can somehow do the work of a whole team. Okay, so what is the event loop, really? Well, you can think of it as this endless cycle that's always asking one simple question. Hey, is there anything for me to do right now? But here's the crucial part. Its job isn't just to do the work. The real genius is in offloading it. See, instead of just sitting there waiting for some slow task to finish, the event loop says, you go do that, I'll be back when you're done, and it just moves on to the next thing. That one simple idea is the entire secret to how Node handles so much at once. So let's map this back to our chef. It's a perfect analogy. An order in, that's a new request coming to the system, maybe to read a file. It goes into the queue. Now, the chef doesn't just stand there and watch a soup simmer for an hour. No way. They delegate it. They put it on the back burner. That's Node offloading a slow task, like reading from a disk. And while that soup is simmering, what's the chef doing? They're chopping veggies, prepping salads, all the quick stuff. That's the main thread, the call stack, executing other code. Then, ding, the soup's ready. A little bell rings. That's our callback, telling the chef, hey, that thing you delegated is done. The chef can now serve it. See? It's all about staying busy and never just waiting. Okay, so this whole delegation model is obviously super powerful. But you can imagine, right? Juggling all those different tasks, it can get really, really messy. So naturally, over the years, the JavaScript community has been on a quest to find better ways to manage this asynchronous world, to move from total chaos to something a lot cleaner. And you can actually see this evolution pretty clearly. It started with callbacks. I mean, they worked, but they led to this deeply nested code that was just a nightmare to read. Then came promises, which were a huge step up, a much cleaner way to handle things. But the real game changer, the thing we use all the time now, is async await. And here's a key thing to remember. It's not some brand new technology. It's really just a beautiful, clean layer on top of promises, what we call syntactic sugar, that makes async code look and feel incredibly simple. And just look at this. This shows you exactly why that evolution was so important. On the left, you've got callback hell. We've all been there. It's that pyramid of doom just marching its way across your screen, and it's almost impossible to debug. But on the right, that's the exact same logic, but with async await. It reads like a story, from top to bottom. It's clean, it's linear, and that's the whole point. You get all that non-blocking power, but with code you can actually understand and maintain. So, Node isn't just about handling async stuff. It's not an empty toolbox. It comes packed with a bunch of really powerful built-in tools, modules and objects that let you talk directly to things like the file system, the operating system, the whole shebang. And one of the biggest ones is the global process object. You should really think of this as your app's command center. It's how you do things like access environment variables, for secret keys and stuff. It's how you can shut down your application gracefully with specific exit codes. You can even use it to listen for system signals, like when someone hits Control-C. It's literally the bridge between your code and the world it's running in. Okay, let's bring this back to the file system module, FS. This is where our chef analogy really shines. Using a synchronous method like read file synchronously, well, that's our bad chef. They're just standing there, watching the soup boil, doing absolutely nothing else. The whole kitchen just stops. That is exactly what we mean when we say blocking the event loop. But the asynchronous version, read file, that's our smart chef. They delegate the task, turn around, and immediately start working on something else. The restaurant keeps running. It's a huge, huge difference. But what happens if you're dealing with like a massive file, a 10 gigabyte video or something? You can't just load all of that into memory at once. You'd crash the server. That's where streams and buffers are your best friends. Think of a stream like a water hose. You get the data piece by piece, not all at once in a giant tidal wave.
And a buffer, that's like a little bucket that holds each chunk of raw data as it comes through the hose. It's an incredibly smart way to handle huge amounts of data without blowing up your memory. Node also gives you a couple of other handy global helpers you'll see everywhere. Dir name and file name are absolute lifesavers. They give you the path to the current directory and file, which means you can build file paths that will always work, no matter where your code is running from. And then there's the global object. If you've ever done browser development, it's pretty much Node's version of the window object.
All right, so we've got our engine, we've got our tools. What's next? Well, we need to talk about how we actually structure all our code. And, just as importantly, how we make sure our app doesn't just fall over when something unexpected happens.
So for organization, Node is all about modules. For a long time, the standard was CommonJS, or use require to pull in other files. But the modern way, the way the whole JavaScript world is going, is ES modules, using import and export. And they look similar, but there's one really big difference under the hood. ES modules load asynchronously, and that, of course, fits perfectly with Node's whole non-blocking philosophy. And let's be real, things are gonna break. It's just a fact of life in programming. So how do we handle it? Well, for your standard synchronous code, it's the good old try-catch block. For promises and async await, you just tack on a .catch to handle any problems. But what about the errors you never saw coming? For that, there's a last-ditch safety net on the process object called uncaught exception. Now, this isn't for trying to fix the problem. It's your one last chance to log what went horribly wrong before you let the application shut down gracefully. Look, if you walk away with just one single thing from all of this, let it be this. Node.js is so powerful for one simple reason. It delegates. It does not wait. Just like our super efficient chef, it gets amazing performance by handing off the slow stuff and never ever just sitting around doing nothing. So yeah, the core engine is actually pretty simple when you break it down, but it's what lets us build these massive scalable apps. We've seen how the event loop, the async patterns, all the built-in tools, they all fit together. So the only real question left is, now that you get how it runs, what are you going to build with it?